Okay, so let's have a quick look at integers. Now, an integer is a whole number which is positive or negative, including 0. So there's no fractional quantity. And I've drawn the Zellum set down below. Zellum is just a posh German symbol to denote the integers. It's written here. You've got this posh Z. And we've got the set there of all the integers. Now there's an infinite amount of integers. That means they go on forever. And the 3 dots before the -5 here just denote that there's an infinite amount of integers below -5, less than -5, and the 3 dots here say that there's an infinite amount of integers greater than 3. Okay, so let's have a look down below. Here I've partitioned, and that is to say I've taken a bit of my set above the list of all integers, and I've just looked at the negative integers. And I just want to show you on the number line below that I can write these negative integers here. And the same goes for the positive integers here. Okay, so the number line below represents a group of integers from -20 to 20. And we say that those integers above 0 are positive. So let's say we've got n, which is greater than 0, and those below 0 are negative. So we've got any number negative. Okay, so the increments on our number line are not graded. So let's see how many we have. Okay, so we share in a distance of 20 divided by 1, 2, 3, 4, 5. So 20 divided by 5 is 4. So let's fill in our number line. So we've got 4, 8, 12, 16, and 20. And the same is true below 0. We've got -4, -8, -12, and -16, and -20. And just to warn you that there are different number lines, and the increments may not be graded, and you may have to work these out. So let's have a practice doing that then. I'm going to give you a new number line, and I would like you to work out each increment. Okay, so let's do that. Red one. Let's say 0. Let's stick to 20. -20. And let's do nice easy one. Okay, so pause the video and see if you can fill in those increments. Okay, so hopefully that was nice and easy and you've done that. So we've got 20, we've got 2 increments, so each one is worth 10. And if we add another 10 on, we get to 20. And we've got -10, and if we add another one on, we get to 20. Okay, so I don't want to spend any more time on number lines, and I just want to look at the next slide. Okay, so there's certain properties of real numbers or integers. Let's write what we're doing, integers. Okay, so for instance, 2 plus 3, which we all know is 5, can be added 3 plus 2. Both are equal to 5. So we can do addition and subtraction in any order. The same is true for multiplication. 2 times 3 is the same as 3 times 2, which is 6. So let's have a look at subtraction. We've got 3 negative 2 is the same as negative 2 plus 3. Okay, well 3 negative 2 is 1. And then we've got negative 2 plus 3 is 1. Okay, so we're going to be taking a closer look at addition and subtraction of negative numbers on the next slide. And I just want to go through the distributive property. And all that says is that we can break a number up into components, and we will get the same answer if we multiply the individual components compared to multiplying the original number. Let me give you an example. Let's do 2 times 5. We all know that is 10. But we can break up that 5 into 3 plus 2. And we can distribute that 2 by 3 and 2. So 2 times 3 is 6. 2 times 2 is 4. And that is equal to 10. Okay, so let's take a closer look at the distributive property. And I just want you to pause the video here and just understand the diagrams and what I've done, because the distributive property is essential for understanding the next proof, if you like, which I'm about to do. So pause the video and see if you can find out where each of the numbers come from using the diagram. Okay, so hopefully you've done that now. So we've got 2 times 6, which we all know is 12. So I've just represented this 6 with a diagram here. So we've got 1, 2, 3, 4, 5, 6 squares, and we've partitioned that 6 into 2 and 4. 4 plus 2 is 6. Okay, so I've got my 2 and 4 here. So I'm going to multiply them individually. 2 times 2 is 4. I've got 4 here. And 2 times 4 is 8. Add them together, we get 12. Okay, so pause the video and do use the distributive property using the diagram here for 2 multiplied by 10. Okay, so hopefully you've done that now. So we've got our 10 block here, and we've partitioned it into 4 and 6. So let's do that then. So we've got 2 multiplied by 4 plus 6. And we know from the previous slide that is the same as 2 multiplied by 6 plus 4. Using the commutative property. Okay, so let's distribute that. So we got 2 times 6 is 12. 2 times 4 is 8, which is 20. And we all know that 2 times 10 is 20. Okay, so we're going to use the distributive and the commutative property to explain the following. Okay, so you should all know the rules for multiplying integers. But we're just going to have a closer look at what we get when we multiply. Let's use an example. 2 multiplied by negative 3 and negative 2 multiplied by negative 3. Let's pretend we don't know the answer. Now, we do know the answer to 2 multiplied by 0. Anything multiplied by 0 is 0. Let's rewrite that 0 as 3 minus 3. 3 subtract 3. So we've partitioned the 0, we've broken it up into some components, and we could have chosen any two numbers, 5 and 5, 6 and 6, as long as they add together to make 0. Okay, so let's distribute this. We got 2 times 3 is 6, but we don't know what a positive times a negative is. But we know the answer must be 0, because 2 times 0 is 0. So in order for this sum to equal 0, this must be negative 6. So here we can deduce that a positive multiplied by a negative is a negative. And if you remember from our previous slide, multiplication is commutative. It doesn't matter which order you do it. So we can say that a negative times a positive is also a negative. Okay, so I'm just going to put those in a little box. Okay, so let's imagine we don't know what a negative multiplied by a negative is. But we do know what something multiplied by 0 is. So a negative 2 multiplied by 0 is definitely 0. Okay, so let's get negative 3 plus 3. Let's do it the other way. Okay, so we're going to distribute this and this. Okay, we don't know what a negative times a negative is. So I'm going to put that in a box. We don't know what it is. But we do know from here that a negative times a positive is a negative. So we know that this is going to be negative 6. But we know that the sum is equal to 0. So the only thing that we can put here is a positive 6. So we can deduce, therefore, that a negative multiplied by a negative is a positive. A negative multiplied by a negative is a positive. Okay, now I would like you to pause the video and make sure you can understand this. This is really important, that you're able to understand that a positive times a negative is a negative multiplied by a positive is a negative, and a negative multiplied by a negative is a positive. Okay, so let's summarize the results, and we should all know that multiplication is the inverse of division. I'm just going to demonstrate that here. Okay, let's say we have a number 4, and we're going to multiply that number by 3. 3 fours are 12. If we want to get the original number, we divide by 3. So multiplication is a consequence of division, and division is a consequence of multiplication. They are inverse operations. The same is true of addition and subtraction. If we got 4, we can add 6, which is 10. To get back to the original, I subtract 6 to get 4. Okay, so let's summarize our results for addition and subtraction. Okay, for multiplication and division then. Multiplication, division. Okay, we've got, let's do this in green. So we got a negative and a positive and a negative and a positive. Negative, positive, negative, positive. And I would like you to fill these in. Okay, so hopefully you've done that now after pausing the video. So we got a negative times a negative is a positive. A negative multiplied by a positive is a negative. And a positive multiplied by a negative is a negative. Positive times a positive is a positive. Now, I'm just going to fill this in. Now, hopefully you can notice that they are identical. So the same rules which apply to multiplication apply to division. So let's look at some examples. I'm going to do 4 examples, and I would like you to pause the video to see if you can do them. I'm going to say, let's do 3 subtract -1. Let's do -3 plus -1. Let's do -3 plus a positive 1. And let's do -4 subtract -5. Okay, pause the video and see if you can have a go at doing these. You can use a number line if you like, but it's not essential. Okay, so hopefully you've done these, and hopefully you can see that a negative multiplied by a negative is a positive. So we can rewrite this. So this now becomes 3 plus 1, which is 4. Okay, so we got a positive multiplied by a negative. So we can rewrite this as a negative, which gives -4. We've got 2 positives, and we know that a positive multiplied by a positive is a positive. So this gives -2. We can rewrite this as a positive. So we get -4 plus 5 gives 1. Okay, so let's have a look at some more examples. Let's try division and multiplication. Let's use red this time. And you can pause the video. Let's do -3, 2, -2 times -3. We've got 3 -2 multiplied by, let's do -5, and 4. We've got -3 multiplied by -3 multiplied by -3. Okay, so pause the video and see if you can do these. Just going to put these in brackets. Okay, so hopefully you've done these. Using our rules of negative numbers, we've got -6, we've got +6, we've got +10, and here we've got a negative multiplied by a negative multiplied by a negative. Okay, so let's do this step by step. So we know a negative multiplied by a negative is a positive, 9. And we can then multiply it by a negative. And we know a positive multiplied by a negative is a negative, so we get negative 27. Okay, so let's have a look at some more examples. Okay, so let's do negative 1 squared. 2, we've got negative 2 to the 4. 3, let's do negative 10 divided by negative 2. And let's do negative 20 divided by negative 5. Okay, so pause the video and have a go at doing these questions. Okay, so hopefully you've done these questions. So listen for the solutions. This sign here is a square, and it means that we need to multiply the negative 1 in this instance by itself. Okay, so we know a negative multiplied by a negative is a positive, so we got positive 1. Now, see if you can decide what you think negative 2 to the power of 4 is. So hopefully you've done that now, and I'm just going to write the meaning down. Got negative 2 multiplied by itself 4 times. So I'm going to do these step by step. We know that a negative times a negative is a positive. 2 times 2 is 4. We've got a negative times a negative is a positive. So we've got positive 4 times positive 4, which is 16. Okay, so the rules for division of negative numbers are the same as multiplication. So I'm just going to rewrite this as a fraction. It makes it easier to see what we're actually doing. So we've got a negative 1 divided by a negative 1, essentially. That's what negative divided by negative is. That's going to give a positive. And 10 divided by 2 is 5. Let's rewrite this. We've got negative 20 over negative 5. Essentially, that is the same as negative 1 times 20 all over negative 1 times 5. We know that a negative divided by a negative is a positive, and 20 divided by 5 is 4. Okay, so let's have a look at some more difficult examples. Okay, this time let's do 5 questions. So question 1, let's do negative 2 cubed divided by negative 8. Let's do negative 3 squared divided by positive 3. Let's do negative 5 squared divided by positive 5. Let's do negative 2 cubed times negative 5 squared all divided by 10, and let's do negative 3 to the 3 multiplied by negative 2 to the 3, all divided by, let's do 2. Okay, so pause the video. You can check the results with a calculator. Okay, so hopefully you've done these. Let's do the solutions in yellow. Okay, so let's write what these actually mean. So we've got negative 2 multiplied by negative 2 multiplied by negative 2. And I'm going to write the division as negative 8 in brackets. Okay, so a negative multiplied by a negative is a positive, but multiplied by a negative again is a negative. So we're going to get a negative on the numerator. 2 times 2 is 4. 2 times 4 is 8. So we got negative 8 divided by negative 8, which is just 1. Okay, so let's have a go at question 2. We've got negative 3 multiplied by negative 3. Let's put brackets around there so we know what we're doing. Divided by positive 3. Okay, we know that a negative multiplied by a negative is a positive, so we've got positive 9 divided by positive 3, which is just simply 3. Okay, so question number 3, we've got negative 5 multiplied by negative 5. Let's put brackets around there. All divided by positive 5. So a negative times a negative is a positive. So 5 times 5 is 25. Divided by 5 is just simply 5. Okay, so we've already worked out negative 2 cubed. It's here. So negative 2 cubed is negative 8. We've also worked out negative 5 squared. It's here. That is 25. And we need to divide by 10. Okay, so a negative multiplied by a positive is a negative. 8 times 25 is 200, divided by 10. So we've got a negative divided by positive 10 here. So a negative divided by a positive is a negative. And we just cancel a 0 to get negative 20. Okay, so we have not done negative 3 cubed. So let's write that in. We have done negative 2 cubed, which we have found to be negative 8. And this is divided by 2. Okay, so hopefully you can decide what sign the numerator is going to be. We've got a negative multiplied by a negative, multiplied by a negative, multiplied by a negative. Well, a negative times a negative is a positive. So this is going to give a positive answer, and so is this. So the numerator is going to be positive. So we've got 3 times 3 times 3, or 3 cubed. So we've got 3 cubed is 27, and then we've got 27 multiplied by 8. So we've got 27 multiplied by 8, which gives 216, divided by 2, which is 108. Which is positive. Okay, so hopefully you're clearer on negative numbers, and more importantly, why a positive times a negative is a negative, and why a negative times a negative is a positive. Okay, keep up the good work in maths.